Guys, so today we are going to start the lead code today questions, and today we have the questions middle of the linked list in which we have to find the middle of the middle node of the index, right? And we have to return that. So if there are two middle nodes, we have to return the second middle node, and as the example first is showing that you have this 3, right? Index 3, right? You can see here index 3 we have, right? That is the middle of the index, and that's why we are returning the output 3 4 5. That is the output. Similarly, we have example 2 in which we are seeing that the red mark 4 is the index, and that's why we are returning the output 4 5 6, right? Because this is the middle of the index of the list, right? Let's understand the questions, right? So if the first approach, we can take that the linked list we have, right? So if we are checking the linked list at index 0, what we have 3, at 1 we have 1, at 2 we have 7, at index 3 we have 2, at index 4 we have what, 2. So total, if we can see that the total size is 0 to 4, it means its size is 5, right? So this is the linked list we have, and if we divide by 2, total size divide by 2, we will get 2, right? 2, and that will we will get the what, we will get the middle index, right? That is 2. So linked list dot get 2, we will get what, 7. Either if we will have 4 by 2, we will have 2 only, right? So index at 2 we have 7, and that's why we will return the middle index. So n by 2 will be the middle node of index, and we can calculate using, we can store this linked list into an array. If we get 1 by 1 element into an array, we will store the 1 by 1 element. We will have the all the index, and we'll get all the index in the array list, right? And we are putting into array, correct? Linked list to array. So this approach, what we are taking only extra space to create an array, but this is not the very good approach or optimized approach in which we can tell into an interview, right? But the approach is very good, you can use. We will copy all the elements at each index of the linked list into array list. So index is 5 by 2, right? And we will have the index now, the middle index 5 by 2, that is 2, array of 2, we will get 7, correct? This is the array, and we have array at index 2 is what, 7. So now if we speak about the time complexity, we will have on, because it will travel for all the elements, and all the index or element, you can say. We are taking extra space of size n, right? And that's why space complexity, because extra space means extra array we have taken, right? We will not take the array, this will remain as 1. So we will see in the next approach, in which we will see the space complexity is 1. But as we go through this approach, you can see that we will take first array list, right? And we'll give the name array. So initially I'm taking a space 0 of the linked list of the node, you can say, ALI list node, you can say, of this. So while head not null, what we will do, we will add the head on array list. Then we will move head dot next, we will update the head, and we will increase the length. And when we return to the middle of the index, right, what we have to do, array dot get length by 2. Whatever the length we have, we will divide by 2. and that will be our middle of the index. Okay, middle node we will get, and that's why the time complexity is what, on, and space is 1 due to extra space this one. We have taken extra space this one. Okay, next we have approach in which we can take two things, the middle node, right, and the last node, right. As you can see, if we will move from here, right, so if only only one node is there, so middle will be this one, middle is this, and the last node is also this one only. Okay, but if we are increasing, if we have element like this, right, so we are increasing one dot next, right, one node only, middle will increase one, and the last node will increase by two node, or some people also say fast and slow. Okay, you can consider m is middle node is a what is slow, and the last node is what, fast. Okay, so we will go with next into next, and middle will go middle into next, means this is slow and last one is fast. So if this will go, middle will go to here, right, last node will go to where, here. Next time middle will move to here, and last node will move where, at this point. Okay, so no need to move to the next uh, node, because this is the last node, and that's why we got this index. This index is called the middle of the index now. So as we compare one by one element, right, so middle is here and is here only, both are at the same place. Now middle will move to here and will move to here only, both will come to here. But when we'll come to middle will come here, next will be what, at the last, right. Similarly middle is here, then it will move last will move to the next. Similarly middle will move to here and last will move to here, like this only it will move, because one is fast and one is slow. The last node is what, faster, and middle node is slower. So in this case we are not taking extra space but the time complexity remains for all the elements, all the nodes, and that way time complexity is on, but the space complexity is what, o1, because we are not taking extra space. So we have taken a middle and both are at head. We will check if and is not equal to null, and and dot next is not null, right. And should not be null, and dot next should not be null, correct. In that case what we'll have to do, we have to update middle dot next and equal to and dot end. Okay, this is faster and this is slower. Okay, so once the while loop is completed, we have to return the middle, and we will get the middle node, and that's why the time complexity will remain on, but the space complexity is on, because we are not taking extra space. Okay, so thank you guys. If you have any comment, please comment into the comment box, and please like, share and subscribe our expert funda. Thank you so much.